This is number 17 on the March 2021 instance of the SAT exam. This is a geometry problem. Let's see what it says. In the figure shown, BC is parallel to AD and AB equals CD. What is the perimeter of quadrilateral ABCD? Okay, so in this test, the document that I found, they didn't categorize this as easy, intermediate, or difficult. I would argue this is probably difficult for most people, because a lot of geometry problems, they you got to combine a lot of concepts, so that's what makes it difficult. Okay, so let me explain how to solve this. We can still get this under 1 minute as long as we have concepts down. Of course, I'm going to explain it slower, but let's see what concepts do we need. So we could categorize this guy as an isosceles trapezoid. Not that categorizing it will actually help us in any bit, in my opinion, but a trapezoid has two parallel sides, okay, which this does because it says BC is parallel to AD. And then this is an isosceles trapezoid because they say AB equals CD. These two other sides are congruent, okay? So we could categorize it. Honestly, the reason I say it won't help because I don't remember any property that can help us, any properties of isosceles trapezoids. There might be one, to be honest. I just don't know. So that's why I'm arguing that it won't be helpful here. Instead, as with a lot of geometry problems, a lot of the times, there are like special cases and special rules, but you can derive them. So even if there is a special property for isosceles trapezoids that you can use to shortcut this, you can still derive it from other properties most of the time. That's how geometry works a lot of the time. So let's see how we can get the answer using other properties. So notice this is a vertical height of 6 here, yeah? So we can extend this vertical height from point B down to AD, and similarly from C down to CD, because these two segments are parallel, yeah? So this point downward is still a length of 6, whoops, and this point downward is still a length of 6, okay? We'll use that to our advantage in a little bit. And then notice that if we extend it down, okay, then we'll have this segment. So that's what I drew over here. This segment is 10. And then because the triangles that result are congruent, actually, we have to notice that. I'll explain in a bit. Then this length remaining over here is x, and this length over here is x as well. Let's see why they are congruent and that we can actually do this. On the exam, you don't have to prove that it's congruent. I'm just helping you out here to see and understand why they're congruent. If you make this guess on the exam, it'll be fine as well. But obviously, I would recommend that you understand why. Okay, so why are these two triangles congruent? Well, I didn't draw it here. This is a right angle over here. It's the vertical height. Okay, that's number one. Okay, and then these two heights are length of 6. Okay, and then they give us this hypotenuse is congruent, AB equals CD. So I think this is a corollary or something like that. If you have in a right triangle, if both the hypotenuse and one of the legs are congruent, then the two triangles are congruent. Okay, and you can derive that from other properties. Or we can understand that since this is congruent, this is what I wrote. Since this hypotenuse is congruent and this vertical height is congruent, we can get this final length by the Pythagorean theorem. It's a right triangle. And then you obviously, since these two are the same by the Pythagorean theorem, the value of this length will be the same as well. Okay, so that's how we understand these two triangles are congruent so that these two lengths we can notate as x. So 10 plus x plus another x is total 26. And if we solve for x is equal to 8, okay, how does that even help us? Well, since we got this as 8, we know this is 6. So I move this triangle out here. We can get this length over here, which is CD. That helps us because we want the perimeter of this guy, yeah? So CD, again, we can use the Pythagorean theorem. 6 squared plus 8 squared is this hypotenuse squared. So if we do the math, it will be 10, the length, okay? So now we can find the perimeter. 26 plus 10 plus 10 plus another 10. That is 56. Okay, so again, the key ideas are being able to, or key strategies are being able to break this down into different pieces. Okay, so I was able to draw the vertical heights, and that I was able to pick out that these two are congruent so that I can notate these the same length, find this value, and then get this length in the end, because that's the whole goal. You want this length and this length there. These two are the same. So as long as we get one of them, we're good. So I thought, let's somehow use this triangle in order to get it. And that's how I worked my way to think of breaking it up like this. And that's how we problem solve on the spot. That's how I recommend to do it. And that's how I did it.